Hi students, welcome back again to this course, An Introduction to Mechanical Engineering. I am Professor Yao. Materials and stresses. Content for this chapter. Forces in commercial airliners. Tension and compression. Material response. Shear. Keywords: tension, compression, or shear. Sketch a stress-strain curve. The material property known as the elastic modulus and the yield strength. The difference between elastic and the plastic responses of materials. Metal and their alloys, ceramics, polymers, and the composite materials. Factor of safety. Objective. At the end of this chapter, you will be able to identify circumstances where a mechanical component is loaded in tension, compression, or shear, and calculated the stress that is present. Sketch a stress-strain curve and use it to describe how material responds to the loads that are applied to it. Explain the meaning of the material properties known as the elastic modulus and the yield strength. Understand the differences between elastic and the plastic response of materials and between their ductile and brittle behaviors. Discuss some of the properties and the use for metals and their alloys, ceramics, polymers, and the composite materials. Applying the concept of a factor of safety to the design of mechanical components that are subject to tension or shear force, shear stress. Summary: the keywords. Primary functions: they are reliable and do not break. Analyze stresses, strain, and strengths. Be overloaded, deform excessively, or fracture. Conduct a stress analysis. The loading circumstances. Computer-aided design tools. Selecting materials and setting dimensions. Dimensionless quantity. Summary: one of the primary functions of mechanical engineers is to design structure and machine components so that they are reliable and do not break. Engineers analyze stress, strain, and strengths to determine whether a component will be safe or risk being overloaded to the point that it might deform excessively or fracture. Generally, engineers conduct a stress analysis during the design process and the result of those calculations are used to guide the choice of materials and dimensions. When the shape of components of the loading circumstances is particularly complicated, engineers will use computer-aided design tools to calculate the stresses and the deformations. The following concepts are central to selecting materials and setting dimensions in the design of structure and machines. Stress is intensity of a force distributed over an exposed area of material. Depending on the direction in which the stresses act, it can be tension or shear. Strain is the change in length per unit of original length. Because of its definition as a ratio of two lengths, strain is a dimensionless quantity, and it is often expressed as the decimal percentage. Overview: forces in commercial airliners. The keywords: as one of their responsibilities, in reliable and safe manner, when fully loaded, is parked on the ground. The landing gear and wheels create an upward lift force. Family-size automobile sedans encounter rough weather, bend up and down, is buffeted by turbulence. Take into account to meet the design's requirements. As one of their responsibility, mechanical engineers design hardware so that it shouldn't break when being used, and so that it can carry forces acting on it in a reliable and safe manner. Consider Boeing 767 commercial airliners, which weigh up 350,000 pounds when fully loaded. When the airplane is parked on the ground, its weight is supported by the landing gear and wheels. During flight, the aircraft wings create an upward lift force that balance the weight. Each wing, therefore, carries a force that is equal to half of the airplane's weight, which in this case is equivalent to some 70 family-size automobile sedans. Subject to the lift force, the wing bends upward, and if the flight happens to encounter rough weather, the wings will bend up and down by an additional considerable amount as the plane is buffeted by turbulence. The fact that an aircraft's wings are subjected to large forces, that they sag under their self-weight, and that they bend upward in response to the lift force, were each taken into account by engineering when the aircraft materials were selected. The wings are designed to be strong, safe, and reliable, while being no heavier than necessary to meet design's requirement. Homework. Handwriting all keywords and submitting them to Course Facebook. Just do the online quiz. See you next time.